So now we're going to look at how to interpret a line graph, and we have a graph here showing the distance a runner covers during an endurance event. And what we have is, down the bottom we have the hours, and along the side we have our distance in kilometers, right? So we need to look at our travel graph, and it can tell us a lot about how they traveled, how far they traveled, and what occurred when they were at certain points. So how far did they travel in total? Now, as you can see, as the runner moves along, he's going further and further away from where he originally was, until we get to the point here, which is the end of his journey, and he's 40 kilometers away. So this is 40 kilometers he's traveled. Alright, now travel graphs are a little bit different from line graphs, but they contain most of the same information, so it's just about reading off the graph and interpreting it correctly. How far did the runner travel in the first hour? So in the first hour, the runner traveled between these 2 points, and that means that his total distance traveled, well, that's just where this intersects. So he traveled 10 kilometers in the first hour. Now for C, we have what is happening between the hours of 4 and 5. So these 2 hours here, we're not seeing any increase in the kilometers traveled. So at this particular point, he is stationary and perhaps at rest. So let's just put stationary. Okay, when is the runner moving at his fastest? Now this line here is showing that he basically increases between the first hour 10 kilometers. So he's running at about 10 kilometers per hour here, again here, and again here, and then we start to slow down. So after that, he travels in 1 hour 5 kilometers, then takes a rest, and then finally another 5 kilometers. So his fastest speeds are between when he starts and the 3 hour mark. So for D, this will be from 0 to 3 hours. Okay? Okay, welcome back. So here's one for you guys to practice. So just give it a go, and then I will solve it. Just remember, down at the bottom we have hours of the distance traveled. Okay, let's get going. So we have another travel graph here, and it's a car going on a road trip, and it's traveling a certain distance. So first one is A, and they're asking what is the total distance the car traveled. So if we go to our endpoint, we can see that we've traveled 250 kilometers. For B, we have how far did the car travel in the third hour. So if we go to our first hour, we've traveled from 0 to 1, our second hour we've traveled from 1 to 2, and our third hour, which is from 2 to 3, we haven't moved at all. So we traveled 0 kilometers, and that's because there's been no change in the vertical nature between 2 and 3 of the line graph. So let's look at C. What is happening between hours 2 and 3? Well, we're stationary, we're not moving. That means we're on a break. We've reached maybe a first point of our destination before we moved on to somewhere else, something like that. Alright, for D, when is the car traveling the fastest? Now the car is traveling the fastest when it increases its distance in comparison to time the most. So it's where the line is the steepest. Now the line is going to be the steepest where we have the most kind of vertical units traveled per horizontal unit. And for this one here, we've traveled 3 vertical units, so we've traveled every single one of these is 25, so we've traveled 75 kilometers in this particular hour here, and this one here we've traveled 50 kilometers here, and then 50 is here as well, and 50 is here, And in the final part, we only traveled 25. So the fastest point is going to between hours 1 and 2. So between 1 to 2 hours. Okay, so that's really just our second hour of travel. You could also write that. At that particular point, we've gone 75 kilometers in 1 hour. Alright, that's it for this video, so I will see you in the next one.